Now we are going to derive a formula, an equation for the distance between a point Q, this point maybe, and a plane. The equation of a plane is ax plus by plus cc equal d, and the normal vector is the vector a, comma b, comma c. And the unitary normal vector, so the normal vector is equal ai plus vj plus ck, being a, b, and c the coefficient of the equations of the plane. Okay. How we are going to find this distance, the distance between the point and the plane, the perpendicular distance? The method is like this. Choose a point P on the plane. Who is the point P on the plane? Any point P on the plane. See what is QP. QP is this vector. Perfect. How you will find the distance D? How you will find this distance D? This one, this distance D. Well, if you are in the plane and you project QP onto this direction, you will have the distance D. What I'm saying is that the distance D, the D is the magnitude of QP, the magnitude of QP by the cosine of this angle. And this can be written like QP dot a unitary vector. Guess which unitary vector is? Is the normal vector, this one. The normal vector n, unitary. If you project onto the normal vector n, unitary, you find the distance D. So the distance D is QP dot n in magnitude. If the dot product is negative, you will use the magnitude. So this is the distance D. Let's go to do a problem to make sure that we can use this equation. So it's clear that if you have the plane, let's go to do it again. If you have the plane and you have the point Q and you have any point P, let's say this point P, if you project onto the normal, when you project onto the normal, if you project QP, the vector QP, projecting onto the direction of the normal, you will find this D. So the distance between the point and a plane is QP dot unitary vector n. Very important to find the unitary vector n. Here it comes the unitary vector n. QP dot the unitary vector n is the distance D. Okay, let's go to do one example. Okay, now let's go to solve this problem to make sure that we understand what we have done. Let's say that we have the point q1, 5, minus 4. Or the vector OQ will be 1i plus 5j minus 4k. Let's say that we have the equation of the plane 3x minus y plus 2z equals 6. So I can choose a point P on this equation. The point P could be 0, 0, 3, because when x equals 0, 3 by 0 is 0. When y equals 0, minus 0 plus 2 by 3. 2 by 3, 6, so 6 is equal to 6. So this point is on this plane, So we have the point Q outside the plane. We have the point P, any arbitrary point P, and we have to find the distance from the point Q to N, the distance perpendicular to the plane. So the distance, we are going to find this distance. this is P, let's say this is P, this is Q, we are going to find QP, and the distance that we are finding is this distance, this one, D, the distance perpendicular. This line make a 90 degree with the plane. So it goes in the direction of the normal vector. Okay, what is the distance? The distance is QP dot the vector normal unitary. QP, the vector normal unitary, is this distance. If you project QP, if you project a vector QP onto the direction of the unitary vector normal, you will obtain this distance, this one. That is the distance from the point to the plane. So the distance from the point to the plane is QP dot n, unitary vector n. And I put a magnitude here. In mathematics, we put the magnitude like this, not to confuse with the absolute value. Well, if we put the magnitude because it may be possible that this dot product can be negative. So if it's negative, we take the absolute value. Okay, let's go to do the problem. Find QP and find the normal vector. Find the normal vector is very easy. I have the equation of the plane, and the normal vector is here, 3 minus 1, 2. If this is the normal vector, what is the unitary normal vector? The unitary normal vector is, let me see if I calculate here. No, I didn't do it yet. The normal vector n is the vector 3, minus 1, 2. And the unitary vector n, unitary, is 3i minus 1j plus 2k divided by the magnitude of n. The magnitude of n is 3 squared, 9, plus 1 squared, 10, plus 4, plus 2 squared, 4 square root of 14. So this is the unitary normal vector n. So find QP. QP is OP minus OQ. OP is 0i plus 0j plus 3k. OQ is the vector that goes from O to Q, is 1i plus 5j minus 4k. Subtract I by I, and you will have that QP is this vector. So let's go now to use our equation to find the distance between the point, this distance, the distance between the point Q and the plane. The minimum distance is this one. So the distance D is the magnitude of QP dot U. Okay, I have QP. QP is the vector minus 1i minus 5j plus 7k. I think the 4, yes, I didn't make any mistake, dot U. And U is the vector 3i divided by square root of 14, 3 divided by square root of 14, I, minus 1j, minus 1j square root of 14, and plus, plus 2k, right? 2k plus 2 divided by square root of 14k. And the dot product is minus 3 divided by square root of 14 plus minus is plus 5 divided by square root of 14. Okay. And plus 14 divided by square root of 14. and this is 1 divided by square root of 14 that multiply 5 minus 3 is 2. 2 plus 14 is 16. So it's positive, good, I don't have to take the absolute value. So the distance is 16 divided by square root of 14. And the final solution is that D is 16 divided by square root of 14. If this number, the dot product, were negative, you take the absolute value. And that's all. Good luck.